For millennia, humanity has sought the secret to a perfect smile. From the ancient Egyptians,
Today, that ancient wisdom is transformed by massive industrial engineering. This facility bridges the...
It begins with calcium, specifically calcium phosphate, sourced from high-quality, ethically processed animal.
These enter slurl. Before processing, every fragment undergoes a rigorous multi-stage purification. Any residual or
This is a continuous flow operation.
Precision is paramount. Advanced optical sorters scan every fragment with laser technology, identifying and ejecting.
The first fracture. Massive hydraulic rollers exert tons of pressure, breaking the material into uniform pebbles. At the molecular level, we are looking for hydroxyapatite.
Even at this early stage, quality control is relentless. Samples are tested for mineral concentration and moisture.
With the raw materials purified and prepared, they are ready for the crucible. Next, we enter the heart.
we now enter the thermal heart of the process. To transform raw fragments into medical-grade abrasives, we must use...
The primary tool is the rotary kiln. This massive, rotating cylinder ensures that the material is constant.
inside, the material is subjected to an oxygen-controlled environment. As the temperature climbs, a critical process called
Initially, the material turns into bone char. This carbon-rich state is a precursor.
Precision is the difference between a high-quality abrasive and a useless byproduct. Infrared sensors monitor the internal temperature.
As the minerals exit the furnace, they must be stabilized. A rapid cooling sequence prevents the crystals from growing too large, which...
In the final stage of calcination, an influx of pure oxygen triggers a secondary reaction. This oxidizes.
The physical properties have shifted. What was once tough and flexible is now brittle and crystalline. This friability is essential.
The heat has created a highly porous structure. These microscopic pores increase the surface area, allowing the purified, whitened, and structurally transformed. The minerals are now ready to be resized. We leave the world of...
Welcome to the Precision Hall. Here, the calcined minerals we created in the furnace are refined.
The first stage of reduction happens in the ball mill. Inside this rotating titan, thousands of high-density ceramic spheres.
It isn't just about crushing. The constant impact of this
For the highest quality toothpaste, we go further. This is a fluid energy jet mill. Unlike the ball mill, there are no grinding media here.
In this vortex, the particles collide with each other at incredible velocities. This autogenous grinding in
Size control is handled by a centrifugal classifier. Only particles small enough to pass through the spinning blades, typically under 20
Rotations. We verify the results using laser diffraction. We are looking for a perfect bell curve of particle distribution.
This precision is measured by the RDA, relative dentin abrasivity.
The result is a mineral flour, so fine it behaves almost like a fluid. This is the...
With our solid foundation ready, we move to the next challenge, creating the liquid matrix that will carry these minerals in specs.
A mineral powder alone cannot clean teeth. To make it functional, we must create a liquid matrix.
The primary ingredients here are humectants, typically sorbitol or glycerin. These are clear, sweet-tasting.
These substances are hygroscopic. They literally pull moisture from the air. In the world of oral care, this is the secret to shelf life.
The ratio of liquid to solid is controlled by high-precision electromagnetic flow meters. Even a 0.5%.
Next, we add the binders, natural gums like xanthan or cellulose. These are the skeletons of the liquid.
We use high shear mixers to hydrate the gums. The blades spin at thousands of revolutions per minute. Consistency is checked in real time. We measure yield stress, the exact amount of force required to make the gel move.
The water used in this matrix is not standard. It is multi-filtered, deionized, and UV treated.
The powders and liquids are now combined into a pre-mix slurry. It is currently a rough, grainy mixture.
But the slurry is missing one final, crucial physical property. To clean the teeth effectively,
For a toothpaste to be effective, it must do more than just sit on the teeth. It must travel.
The most common surfactant is sodium lauryl sulfate, or SLS. Derived from natural oils like coconut.
Watch as it breaks the surface tension. By flattening the water, the surfactant allows the
surfactant solution is now integrated into our master slurry of minerals and humectants. It must be added.
The hydrophobic tails grab the oily plaque, while the hydrophilic heads stay in the water. This lifts the debris away from. Balance is critical. Too much surfactant can cause mouth irritation or sloughing.
Now that the paste can clean and foam, it's time for the most important addition of all, the medicine. We move
Beyond cleaning and foaming, modern toothpaste serves as a daily medical treatment. We are now in the high-security pharmaceutical zone. The most vital additive is fluoride. In the correct dosage, it is the most effective tool in human history for fighting dental caries.
Precision here is non-negotiable. We use volumetric microfeeders to ensure the fluoride. At the molecular level, fluoride performs a miracle called remineralization.
For those with sensitive teeth, we add potassium nitrate. This is a desensitizing agent.
It works by polarizing the nerve. The potassium ions build up outside the nerve cell, blocking the pain signals caused by cold or heat.
These actives are first blended into a concentrate. By creating a smaller, highly potent batch first, we ensure.
Temperature is the enemy of stability. If the mixture gets too hot during this phase, the fluoride can react prematurely.
The ingredients are ready. The minerals, the liquids, and the medicines have been prepared.
We have reached the heart of the facility. This is the master mix. In these colossal vessels and the
Pickle. The primary tool is the vacuum homogenizer. Unlike a standard kitchen mixer, this machine is designed to withstand.
Before mixing begins, we must remove the air. If oxygen is trapped inside the paste, it can lead to oxidation.
Inside, the agitation is multi-directional. Outer scraper blades constantly wipe the walls to prevent dead zones.
The magic happens at the bottom. The paste is forced through a homogenizer valve. This shears the particles, ensuring the bones.
The friction of mixing generates intense heat. To protect the fluoride, the vessel's jacket circulates chilled water.
As the vacuum and homogenization work in tandem, the texture transforms. It moves from a...
We test for stand-up. The paste must be thick enough to stay on a brush, but fluid enough to be pumped through the
Under a microscope, it is a masterpiece of suspension.
The base paste is finished, but it lacks the sensory experience consumers demand.
While the base paste provides the medicine, it is the flavor that provides the experience. We now enter.
Most premium toothpastes rely on mentha piperita, peppermint. These oils are doubled.
The cold feeling isn't a change in temperature, it's chemistry. Menthol molecules. Flavors are volatile, meaning they evaporate easily. To preserve them, they are injected into the
For the iconic white color, we use titanium dioxide. These particles are incredibly efficient at scattering light.
If the product is striped, a second and separate gel is created.
This is the multi-track filling head. This precision engineering marvel allows the white paste and colored gels. As the tube fills from the bottom up, the colored gel is layered onto the edges. Because toothpaste is a Bingham plastic.
Quality control checks the internal architecture. If the stripes are blurred or bleeding, it indicates a pump synchronization error.
The paste is complete, flavored, and striped. Now, it must be sealed within its protective shell.
The production line now accelerates to breathtaking speeds. We begin with the empty shells, multi-layered laminate.
A rotary cassette loader organizes the chaos. Each tube is placed into a precision-engineered cup.
Purity is absolute. Before a single drop of paste enters, each tube is blasted with ionized, sterile air to remove
Surrendering. To ensure the brand logo always faces the consumer, an optical sensor searches for the eye mark. It rotates the tube at
Filling happens from the bottom up. By plunging the nozzle deep into the tube and retracting it as the paste flows, we eliminate air pockets.
Conventional heat sealing is too slow and can damage the flavor oils. Instead, we use ultrasonic sealing. Titanium horns vibrate.
This is molecular fusion. The vibration causes the plastic molecules to weave together. The tail is trimmed. A chilled steel blade removes the excess material, giving the tube its finished, professional look.
Finally, a laser etches the digital identity of the batch. This code contains the manufacture date, the factory line number.
The transformation is complete. What began as raw minerals and organic elements is now a sealed, protected.
Before any tube is released, it must undergo a 48-hour microbial quarantine. We incubate samples at body temperature.
Science never sleeps. We perform a final chemical fingerprinting to verify the fluoride bioavailability.
Engineering stress testing ensures durability. We perform burst tests to verify that the ultrasonic seal is stronger than the tube. Every box is a source of information. Leaflets with medical instructions are inserted, and a unique serialized QR code is applied. Robotic automation handles the heavy lifting. Delta robots, capable of thousands of movements per hour, pack the
titan of the warehouse, the palletizing robot. It stacks the cases in a precise interlocking pattern to ensure stability during sea and air transit.
In this lights-out facility, autonomous vehicles now laser guidance.
The journey that began with raw minerals and fire ends here, in a simple morning ritual. A masterpiece of...
From animal bones to oral protection, this is the science of the smile.